In the name of Allah, the most gracious, the most merciful, I am Engineer Hani Kamil, and in this video I am going to talk about transformer differential relay stability if there is any external fault, especially phase unsymmetrical fault like phase to ground, phase to ground, or double phase fault. And this point is important if our transformer one winding is a star and the other winding is delta, especially in new protection scheme. If we are using the CT in high voltage side and CT in low voltage side is star connected. So let's see how the differential relay will stable for such fault. Now we have DYN1 transformer, and we have external fault, phase to ground fault, and a star winding in R phase or X1 phase. So normally the current will be from X1 going to ground, and then we'll go back through the transformer neutral X0. For current in HV side, as X1, the winding X1, X0 is in same limb of H1, H3, so the current in H1, H3 will be reversed or 180 degree from the current in X1, X0. So we can see the current in R phase or H1 will come and then enter transformer, and then will leave to H3. If we have CT T1 in HV side, and as per the new protection scheme, the star point is connected to the star, and the star point towards the subject under protection, and low voltage side CT T2, them also connected in a star, and the T point or star point is towards the transformer. Let's see the secondary current. For high voltage side, the current in the CT, if the current is from B1 to B2, so inside the CT the current will be from S2 to S1, mean 180 degree also. So from outside CT it will be from S1 to S2. So the current will go from S1 to the relay. We have also current in H3, so the current also will be inside the CT from S1 to S2, means from outside CT from S2 and go back to S1, from S2 and then go back to S1. LV side, same, the current is from B2 to B1, so outside the CT from S2 to neutral point, and then we'll go back to S1. Yellow X2 there is no current, and X3 there is no current, so the current will be 0. So we can see R phase in low voltage side have IX1, and same R phase in HV side have IH13. Yellow phase both sides have 0 current, but blue phase in HV side have current, and in LV side zero current. Of course, like this case, differential relay will operate and will give the command by mistake. Let's see this one by simulation. I already in my model I disabled the filter, or I disabled this facility in the relay. Because the relay have facility to compensate such current, but I disable it. Now I will make phase to ground fault on the busbar, and I disable the busbar protection, so I expect the upstream protection will operate like transformer protection. Now fault, it already give trip, and we can see the disturbance recorder. We can see differential relay already give trip command. We can go and check which phase already give trip. Phase A, and there is no trip in phase A. Phase B, no trip in phase B. Phase C, and we can see there is a trip command in phase C. So if differential relay, I disable this as a facility in relay to compensate this problem. It will give by mistake trip command. So normally in digital relays, they have we can enable the zero sequence compensation, and this one for our transformer vector group dy1, the current on R phase after compensation, it will be ix1 minus ix2. ix2 is 0, so it will be ix1. In yellow phase, ix2 minus ix3, both is 0, so current will be 0. And in the blue phase, ix3 minus ix1, so 0 minus ix1, it will be negative ix1, so it means other negative direction or reverse direction. So we can see now the R phase current will be balanced, yellow phase current balance, and blue phase current are balanced. So we'll go back again to our relay. I will activate the zero sequence compensation, and let's see what will happen. I will clear the fault. Now I will start again. Now transformer is working. I will generate fault. I will make force reset to see all the trip function operated. So in disturbance recorder, we have sensitive earth fault operated. Of course, restricted earth fault didn't operate because it's outside the restricted zone. Then overcurrent and LV side and HV side operated, and differential didn't operate. It's now stable. And so of course, R phase there is no differential, yellow phase no differential, and blue phase there is no differential. What about thesis for digital relay? What about the electromechanical relay? Before all the scheme, star winding, the CT will be connected in delta, and the delta winding, the CT will be connected in star. So for star winding, as we said, x1, x0 is in the same limb of h1, h3, so the CT in x1 will be will be connected to x1, and the s2 will be connected to h3 sorry s3 x3, so it will give the same angle or give the right angle compensation, because we know that low voltage side is lag high voltage side by 30 degree. So by connecting the CT in delta will give also another 30 degree, will compensate the current or the angle between high voltage side and low voltage side. This is first point of using delta. Second point, if we see the current, so the current in delta side or in x1 ct will be from s1 to s2 inside the ct, so outside ct from s2 going to s1. So the current outside delta, we know the current law. If all the summation of the current entering one point is equal to the summation of the current leaving the point, so this is our point. So now the current leaving the point equal the current entering the point. So our phase current Ix1 will be in this direction and will equal Ct Ix1 Ct current, and then this point the current here is 0 and high impedance, so the current cannot of x1 cannot enter this direction, only can leave the delta and will go to the relay. The ct in x2 the current is 0 and also have a high impedance, so the current will be 0. So the current outside delta we have in R phase Ix1, which will be stable with R phase in HV side. Yellow phase current is 0, same HV side, and blue phase current is Ix1, also will be stable with IH13. This for phase to ground fault. Next we have double phase to ground fault in X1 and in X0. So in X1 the current will be Ix1 going to ground and going back to the neutral point, and in X2 current Ix2 then going to ground and come back again through X0 or neutral point. Already in LV side we have current Ix1 means going from X0 to X1, so again the current will be IH1 to 3 means IH1 3, and X2 current will have LV side current reverse direction IH21. Now we need to know the current outside delta. We know that as per the current law of point or node, the summation of current entering the point equal to the summation of current getting out this point, and we'll assume that all the current inside delta from H1 to H3 to H2 to H1 and all current outside delta is trying to enter the delta. So IH1 equal to IH13 minus IH21, then IH2 equal to IH2 minus IH32, which is 0, so will IH2 will equal to IH21, then IH3, which we assume it's entering the delta, equal to IH32 minus IH13, so 0 minus IH13 equal minus IH13, so it will be in reverse direction, means getting out the delta. Again we are using star connect CT in HV side and LV side. So the current in secondary side in Ix1 will be in this direction, reverse to the primary side. Current in Ix2 will be reverse to primary side, and there is no current in Ix3, so we have Ix1, Ix2, and 0 current in blue phase or Ix3. In HV side we have an R phase IH13 minus IH21, yellow phase IH21, and blue phase IH13. So now we have an equal current between in R phase and in blue phase, so expect the differential protection will operate in R phase and blue phase and will give mistake trip. So let's try it. Now I will disable the 0 sequence compensation. I will make double phase to ground fault. Now I will create the fault. Make run. Remove reset. Now I will make fault. We can see it's already give trip. So let's see. The disturbance recorder. We have differential protection. In R phase or A phase we have differential. In B phase there is no trip command, and in blue phase we have trip command. So by this way, if we disable the 0 sequence compensation, differential relay will operate by mistake. After enabling the 0 sequence compensation, which means for dy1 ir minus iy, ix1 minus x2, then iy will be iy minus I blue or P phase, mean ix2 minus 0 will be ix2, and blue phase ix3 minus ix1, which will be minus ix1 in the other direction. So now our phase will have stability. ih1 3 minus ih2 1 equal to ix1 minus ix2. Y phase ih2 1 will equal ix2. Blue phase ih1 3 equal to ix1. We'll go back again to our simulation. In differential relay, I will enable 0 sequence compensation, and again I will make run. And I will make fault, and I will make force reset. Let's see the disturbance recorder. So we have sinus reverse fault. We have overcurrent in each LV side and HV side. Now differential relay didn't work. You can see phase A differential, there is no trip. Phase B differential, no trip. And phase C differential, there is no trip. For all the scheme of electromechanical relay, if we are using delta in star point in star side and star in delta side, so the current in LV side delta NCT, we have current in primary side from P2 to P1, so from inside the delta for the CT will be from S2 to S1 outside the CT, and from S1 to S2 inside the CT we have current Ix2. We have the same in CT also from S2 to S1. So the same as we talked about as we talked before in delta, and how we assume the current, how we calculate it. So the current in R phase will be Ix1 minus Ix2. Then yellow phase will be Ix2 minus Ix3, Ix3 is 0, so it will be Ix2. And blue phase will be Ix3 minus Ix1, so the current will be reverse direction and will means negative Ix1, so it will be Ix1 in reverse direction. So now we have stability IH13 minus IH21 equal Ix1 minus Ix2. This is our phase. Yellow phase IH21 equal to Ix2 yellow phase, and in blue phase IH13 equal to Ix1. Next, we'll go to double phase fault. Now we have X1, X2 fault, so the current will be from X1 through the fault going to X2. Here the current in X1 and X2 already the same, but just reverse direction. That's why I just mentioned I2. In current in HV side for X1, for X0, X1 will be from H1 to H3, and for X2, X0 will be from reverse direction H1, H2. So the summation of the current in H1 will be IH13 plus IH12, and already same magnitude, same phase angle, so it will be just duplication. And the current H1, H3 again same, leading to IH3, H1, H2 will leading to H2. Again we have CTs with star connected. So on LV side, our current and X1 or R1 CT will be reversed to primary, so will be coming in this direction. Current in X2 again reverse direction, and blue phase there is no current, current is 0. In HV side, the current in CT again reverse to primary side, so will be from S1, and the amount will be 2I1, and in yellow phase reverse direction and be I1. Blue phase same will be I1 in reverse direction to primary side. So now we have R phase 2I1 and I2. It will give trip command. Y phase I1 and I2, so it is stable. Blue phase I1 and 0 ampere, so it will give trip command. So now we expect R and blue will give trip command. We'll go to our simulation. We'll disable the 0 seconds compensation, and we'll make double phase fault. And we'll make run. So we can see now we'll make fault. It will give trip. Let's see the sequence recorded. We have differential protection, differential trip, R phase, so we have trip command, yellow phase, stable, and blue phase have trip command. So for after enabling the zero sequence compensation, IR minus IY, it will be I2 minus I2, and this I2 is already negative direction, so it will be summation means I2 plus I2, 2I2, I2 minus 0 will be I2, 0 minus I2 will be I2 in negative direction, so 2I1 equal to I2 stable, I1 and I2 stable, and blue phase I1 and I2 also stable. So again back, enable the zero sequence compensation, and run. You will make fault and force reset. Now let's check further. Only over current operated. Differential didn't operate. You can see phase no trip, yellow phase no trip, and blue phase no trip. In old scheme electromechanical relay, we have delta in LV side, so we have current in R phase CT and like this on opposite direction to primary current, and for X2 current opposite to primary current. So the current in R phase mean outside delta will be summation of these two current, and in yellow phase this current and this current will be 0, so it will be I2 or IX2, and blue phase this current is 0 and this current is IX1, so will be IX1, which already is I2, so we have 2I2, I2 and I2. In R phase 2I1 equal to I2 stable, Y phase I1 equal to I2 stable, and blue phase I1 equal to I2, so it is stable. At the end, thank you for watching my video. I am Engineer Hani Kamil. This is my contact as shown. Any suggestion or discussion you welcome. You can contact me directly. Don't forget to subscribe my channel to get notification for coming video.